Algebraic expressions, Lesson 1. Pause the video and write down these key ideas. Try to find the answers for these questions as you watch the video. Lesson 1. Expanding algebraic expressions. Zoot and Snoot are going to help me. Zoot is the one who always makes mistakes, but he loves learning from them, while Snoot needs to find the most effective method to do the math. I hope the three of us will be able to assist you in this journey of expanding algebraic expressions. Find an expression for the area of this rectangle. We know that area is length times breadth, so Zoot decides to break the big rectangle into two separate rectangles. He then calculates the area of each rectangle separately. For the red rectangle, the area is x times 5, and for the blue rectangle, the area is 4 times 5. This is then 5x plus 20. Snoot wants the most effective method, so he decides to calculate the length of the big rectangle first, and then that will be x plus 4 in brackets. And then he multiplies that by the breadth, which is 5. He uses the commutative property to swap the order of the bracket and 5. So his expression is 5 times the bracket. So who's correct? Zoot or Snoot? Both of them must be correct, because both of them followed the mathematical rules. So these two expressions must be equivalent. Of course, Zoot wants us to prove it. We will. Equivalent expressions are expressions with the same value on substitution with a constant value. Now, what does that mean? It means if we choose any value for x and we substitute that value for x, then the answer of both expressions must be exactly the same. So Zoot's breaking up of the rectangles and Snoot's multiplying the width times the total length must give us the same answer. So we need to try to prove that these two expressions are equivalent. Let's use substitution. So we choose a value for x and then we substitute that value for x. So let x be 3. Then 5 times 3 plus 20 is 35. And 5 times the bracket, which is then 7, is 35. Do you see here we followed order of operation? We first calculated the bracket. So we proved by using substitution that the two expressions are indeed equivalent. Well done, Zoot and Snoot. Let's use the two methods to calculate this expression. Zoot is using the breaking up of a rectangle method. So he multiplies the 2 by the 3 and the 2 by the 4. We say we distribute the 2 to the 3 and the 4. This is why it's called the distributive property. Why is the distributive property so useful? Write down the examples in your math journal. So here is example 1 and 2. In example 1, we can either first calculate the bracket or we can distribute. But in example 2, we cannot calculate the bracket because the two terms are unlike. So here we can use distribution. We multiply the number outside the bracket by each number inside the bracket. So in example 2, 2 times 3 is 6 and 2 times x is 2x, and we have simplified this expression using the distributive property. Let's simplify example 4 and 5. Simplify involves simplifying expressions in such a way that the number of calculations in the expression is reduced. Simplified expressions are all equivalent. Let's look at the two examples. Both examples have a negative in front of the bracket. The first one involves addition of two terms inside the bracket. The second one, subtraction of two terms. Note what happens if there's a negative in front of the bracket. Negative 2x is negative 2x. Negative positive 3 is negative 3. In example 5, you subtract 2x, that's negative 2x. Subtract negative 3 and it becomes a positive. So yes, Zoot, we have to be careful when there's a negative in front of the bracket. So why is the distributive property so useful? Look at example 6 and 7. How are these two examples different to the previous two? Yes, now we've got a number in front of the bracket, not just the negative sign. In example 6, we have to multiply 3x by the bracket. We cannot calculate the bracket since the two terms are unlike, but we can use the distributive property. So let's distribute the 3x by the 2x and the 3x to the negative 3. By multiplying 3x by 2x, that is equal to 6x squared. Remember, 3 times 2 is 6, x times x is x squared. And 3x by negative 3 is negative 9x. In example 7, we must also use the distributive property. So negative 3x times 2x is negative 6x squared. Look at the signs. And negative 3x times negative 3 is positive 9x. Yes, we have to be careful if there's a negative in front of the bracket. What will happen if there are more than two terms in the bracket? That's a great question, Snoot. You always ask what-if questions. Well, then we'll just distribute the number in front of the bracket to each term inside the bracket. Think of your rectangle problem in the beginning. You'll just divide the rectangle into 3 separate rectangles and multiply the areas separately and then add or subtract. So let's distribute. It's easy if you do it sign by sign, number by number, and variable by variable. Negative times a positive is a negative. 3 times 1 is 3. A times a squared is a cubed. Negative times a negative is a positive. 3 times 2 is 6. A times a squared. And negative 3a times positive 3, negative 9a. We cannot simplify this further as these 3 terms are In this example, we've got a bracket times a bracket. We can just swap the order of the brackets using the commutative property. And then we'll just distribute the negative 3m to the 3 and the negative 2m in the bracket. Negative 3m times 3 is negative 9m. And negative 3m times negative 2m will be 6m squared. Yes, be careful of the negative in front of the bracket. Zoot made a mistake. Let's try to help him. This is 7 minus 4 times the bracket. Zoot did not consider order of operation. We have to first multiply. He said 7 minus 4 is 3 and then he multiplied. Thank you, Snoot, for helping us. It's clear that there are two terms. 7 minus 4 times the bracket. Remember, terms are separated by a negative or a positive sign. So we first distribute the negative 4 to the 3x and the negative 3. That gives us negative 12x plus 12. We bring the 7 down and now we can collect the like terms. Do you see that 7 plus 12 equal 19 and then minus 12x, or we can say negative 12x plus 19. In this lesson, we learned about the distributive property of multiplication that states when a number is multiplied by the sum of two numbers in brackets or by the difference of two numbers in brackets, then the first number can be distributed to both of the numbers within the brackets, and then the products can be added separately or subtracted separately. It's a very useful property when we simplify algebraic expressions. I agree with you, Snoot. Okay, let's take a break.